Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so let's have a look at the 2019 question. So a little bit of algebra first. Factorise fully 3xy minus 9x plus 4y minus 12. That was part A. Part B, g of x is equal to 3x ln of x minus 9x plus 4 ln of x minus 12. Use your answer to part A, or otherwise, solve g of x equals 0. And then part C, evaluate g dash e correct to 2 decimal places. So this was the 2019 question. So give this one a go. Okay, let's factorize. So we have 3xy. I see the y's as grouping together. It doesn't matter if you see something different. So I'm taking the y's outside here. When I look at the other two terms, I see a minus 3 and I get 3x minus 4 plus 4. Why plus 4? Because minus by plus gives me that minus 12 that's up here. Remember, I need to get back to the original. That's what factors do. If you had seen different factors, then what normally happens is you will have the outside ones, the y minus 3 on the inner brackets. It doesn't matter because when we group them together, we end up with the same thing. Okay, so that was a lovely grouping question from Junior Cert, really. It's the only time I've seen a grouping on a Leaving Cert paper, so it was a nice little gift. Okay, the kicker came in part B. So they said, let g of x equal to 0. So I'll change to a different color so you can see. So I have 3x ln of x minus 9x plus 4 ln of x minus 12 equals 0. Okay, experience at this stage has taught me that when I see some of the terms the same, so you can see minus 12, minus 12, minus 9x, minus 9x. I see a 3x, a 3x, a 4, a 4. So when that happens, I tend to look a bit closer at the two equations and go, right, what is different as opposed to what is the same? And if you look across at it, you will see that it's y here, whereas it's ln of x here. It's y here, so it's ln of x here. Now, if both of these equations are 0, in that they are when you factorize, okay, then you can conclude then that y must be the same as ln of x. Okay, because that is the only difference that's between the two lines. Okay, so what does this mean? Well, what I would say up here was I would swap my y for ln of x. So I could do the factorization very quickly in that way. Okay, and that's perfectly okay to do, and you can do it the long way to convince yourself that it's the same thing. And when I say the long way, you just factor out the ln of x and you'll get 3x plus 4, factor out the minus 3 again, and you'll see you get the 3x plus 4. So you will end up with this anyway, even if you were to do grouping again. But this is the faster way of doing it. Okay, and then we solve, just like we would any other pair of brackets like this. So ln of x minus 3 equals 0, and 3x plus 4 equals 0. 3x is equal to minus 4, x is equal to minus 4/3. Ln of x is equal to 3. Okay, to solve this, okay, let me go to the log tables. And I'm going back for the rules of logs, which is the middle column, but more so the right-hand column when we're doing this. So depending on your preference, you can use the switch, or you can use one of these two. Okay. Okay, let's have a look at them and see what way to do it. So how I do this is you have to know, though, to do this, that ln of a number is the same as log to the base e. Okay, log to the base e is the natural logarithm, and it's supposed the natural growth rate in nature. And it's so commonly used, especially in science, this natural growth rate, that they gave it its own term called natural log. And they called it ln. Okay, but ln is log to the base e. This e number is a constant. You can check it on your calculator. It is down the bottom if you hit shift or the red button, so alpha and then the by 10x, and you'll see it's 2.71828, so on and so forth. So it's a natural growth rate, it's a constant. Okay, so if I was going to do a switch, I would write ln as log to the base e of x is equal to 3. Okay, and then if you look at this rule here, okay, do you see that the base number is called a, what you're getting the log of is called y, and this number is called x. Okay, and I tend to map it onto here. So this is how you change from a log to an indice. So it becomes a, Ra is e to the power of x, Rx is 3, is equal to y, which is Rx. Okay, you just have to be a bit careful because we have x's and stuff in ours, so you could get a little bit lost in the letters. Okay, but map them just like I did there. You don't fully have to wrap your head around the switch. You will in time, it will become normal and you'll be able to solve for x. So that's it solved. X is equal to e to the power of 3. Okay, you discard this one because you cannot get the log of a negative number. Okay, so that is not that's not a solution to this one. Okay, now I also, if you bear with me, I also like this rule and the top one. They're just the opposite of each other. Okay, so if I could write this one down here again, because you can also do it this way. If it's ln, okay, so that's log to the base e of x is equal to 3. Okay, the opposite of logs is powers. So if I raise this to the base number, so in other words, I always match the base number with what I'm raising. And what I do to one side, I must do to the other. Okay, what you'll find is that e and log to the base e cancel each other out, and you're left with just x being equal to e to the power of 3. Okay, so I tend to use that one an awful lot more than the switch. There isn't one better than the other. It's a bit of personal preference. So that's how you do B. So evaluate G-E correct to 2 decimal places. Okay, so G-E. So to get G-E, I have to first of all get G-X. Okay, so G of x was equal to 3x ln of x minus 9x plus 4 ln of x minus 12. Okay, so that's my G of x, and I've taken that from here. Okay, you've got to be careful because he's a product. Okay, and I know that because I've got a 3x and an ln of x. So I'm going to come up here and do my product. You can do it off to the side either. du dx is equal to 3, dv dx is equal to 1 over x. All of them are coming from the log tables, okay? This one and the top one. So then the product rule tells me that I go u times dv dx plus v times du dx. So it's 3x by 1 over x plus ln of x by 3. Okay, and then x on the top, x on the bottom. So I'm getting 3 plus 3 ln of x. So let's then finish off our differentiation down here. So g dash of x equals 3 plus 3 ln of x minus 9 plus 4 over x, and then the minus 12 disappears. Okay, so if I tidy him up, then I just have two numbers. That's about all I can do to tidy it up. 3 ln of x minus 6 plus 4 over x. I'm not even too bothered tidying it up because they've told me to differentiate or to figure out what g dash e is. Okay, so now just as before, x is being replaced by e. Okay, so that's how we do it typically in functions, and it's the same principle here. Okay, put that all into the calculator because now they're just numbers, and you should get minus 1.53. Okay, correct to do decimal places. Okay, there's a little step in the middle that you could do in that ln of e here is the number 1. So this could be written as 3 minus 6, so minus 3 plus 4 over e, if you wanted to simplify it before putting it in. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.